Now let's proceed with question number 21. This is the first question of section B, which contains 2 marker questions. So here this question states, find the value of this integral. It is integral of x plus 1 upon x plus 2 into x plus 3. By having a look at this integral, you might think this can be easily solved when we split up this fraction in terms of 2 separate fractions. So we need to apply here partial fraction. Very first I am going to consider this as integral I. Now I need to apply here partial fraction. So this fraction can be written in terms of a upon x plus 2 plus b upon x plus 3. So in that manner, here I get this value, where you can easily take LCM on the right hand side, and on taking LCM you will get here a into x plus 3 plus b into x plus 2, where now I need to club the terms containing x and constant term here in the numerator, which will give me a plus b into x, next 3a plus 2b. Next step will be comparing the coefficient of x in the numerator on left hand side and right hand side, as well as for the constant terms. So when you compare the coefficients, you will get here that a plus b is equal to 1, that is coefficient of x, and the constant part will be 3a plus 2b equal to 1. So we have obtained here 2 equations in terms of a and b, which can be easily solved, and on solving that you will get here the value of a as minus 1 and b as 2. This means here we can definitely write this partial fraction as, it could be written that x plus 1 upon x plus 2 into x plus 3 is basically equal to minus 1 upon x plus 2 plus 2 upon x plus 3. So in this manner, the given integral can also be simplified. And when we apply here integral on both the sides with respect to x, here you have to apply integral with respect to x, and here also when you will be applying integral with respect to x, this can be further solved. And you can easily split this in terms of 2 terms, which will give you here the value of this integral I equal to integral of minus 1 upon x plus 2 dx plus integral of 2 upon x plus 3 dx. And you are quite aware that this minus 1 will come out of this integral, and integral of 1 upon x plus 2 dx is simply log of mod of x plus 2, and in similar manner integral of 1 upon x plus 3 will be log of mod of x plus 3. So taking that into consideration, we will further obtain here this as the value of this integral. Here you can clearly see we have obtained here this as the required answer for this integral, minus log of mod of x plus 2 plus twice log of mod of x plus 3 plus c, where c is the constant of integration. So here we get the required answer for this question. So this gives you the final answer. In this manner, in solving this, you will get complete 2 marks, where on splitting up this fraction and obtaining here the value of a as minus 1 and b as 2. So on application of partial fraction and solving this, here you get 1 mark, and finally for solving this part you will obtain rest 1 mark. That gives you total 1 plus 1, 2 marks for this question. I hope that's clear. Now let's move on to question number 22. Here in question number 22, you can clearly see we have a choice. You can opt for any of these two. So here the first part states, if f of x is equal to 4x plus 3 upon 6x minus 4, where x is not equal to 2 upon 3, then show that f of f, that is a composite function of f of x, is equal to x for all x not equal to 2 upon 3. Also write inverse of this function f. And in the second choice, it has been stated, check if the relation R in the given set of the real numbers is defined as R containing a comma b, where a is less than b, and you need to check whether it is symmetric or transitive. So we'll be proceeding with the first choice. In this question you can clearly see f of x is equal to 4x plus 3 upon 6x minus 4, which is clearly a rational function. Denominator has to be a non-zero quantity, that's why x is not equal to 2 upon 3. That means domain of this function will be set of all real values except 2 upon 3. So here I can consider that this function f is definitely a mapping from a to b, where a is set of all real numbers minus 2 upon 3. Such that here I have f of x equal to 4x plus 3 upon 6x minus 4. As I need to obtain here f of f, that is composite function of f, so f of x can be obtained by considering x as f of x. Further, I will be substituting here f of x as 4x plus 3 upon 6x minus 4. And on solving and simplifying this, you will see that here on taking LCM, many terms will get simplified and ultimately you will get here the value 34x upon 34, which reduces to the value x. So we have clearly shown here that f of x is equal to x. Hence we have proved that this composite function of f of x is equal to x. Now this statement clearly tells me that as I have f of f equal to x, this is possible that this composite function is equal to the inverse of a, inverse in the domain of a, where a is set of all real numbers except 2 upon 3. This means f is inverse of itself. So as f is inverse of itself, I can simply write that inverse of this x will be equal to 4x plus 3 upon 6x minus 4. So here we have obtained the required inverse of this function f of x. Moreover, we have shown that this composite function f of x is equal to x itself. So on basis of this, till the step where you show that f of f is equal to x, here you will get 1 mark. And in this step where you have obtained inverse of this function f, here you get rest 1 mark. That gives you total 2 marks for this question. I hope it's clear. Now let's move on to the choice provided in the same question. In this choice, we are supposed to show whether this given relation R is symmetric or transitive. So very first, you can clearly see when we are talking about this relation R defined in the set of the real numbers, here it contains the elements like a comma v where a is less than b. Now in order to check the symmetric relation, if a is related to b and b is also related to a, then only it will be said as a symmetric. So if I consider that a is related to b, this clearly implies according to this given relation that a will be less than b. But if a is less than b, b will not be less than a. That means b will not be related to a under the same relation. That's why it is not symmetric. Now next we need to check whether it is transitive or not. If a is related to b, b is related to c, and it also implies that a is related to c, then in that case the relation will be said as transitive. So if I consider here that a is related to b and b is related to c under the same relation, so a will be less than b and b will be less than c. So this clearly implies that a will be less than c. So a is also related to c under the same relation. So here it proves that this is definitely having a transitive relation. So we can clearly say that this relation R defined in this set of real numbers is not symmetric, but it is transitive. So here for proving firstly that R is not symmetric and secondly that R is transitive, you will get complete 2 marks. In this step you will get 1 mark and in this step you will obtain rest 1 mark. That gives you total 2 marks for this question. I hope it's clear to you. Now let's move on to our next question.